Yo, yo, yo.
Hello, hello.
Hello, hello. Making sure
Double check, double check.
I'm double checking over here. Did you put the broadcast?
Yeah.
Did you? I'm not getting it.
No?
Did you start the stream?
Yeah.
Is it? Let me see. Let me check out mine.
I'm looking too.
Yep, yep, yep.
I see it, I see it, I see it.
You see it? You see it? Let me see. Let me check mine.
Yeah, it's on, it's on.
Yeah. All right, but then it's just me then. Yeah, I got it too over here.
Alright.
Yes, sir.
Woo.
Yes, sir. We are back, baby. We are back with another stream. Yes, sir. We're back. We're back. Yes, sir. How's everybody doing? How's everybody's days?
How you doing, Jose?
I'm doing good, my guy. You know, pretty rested, ready to go, energized, ready to tackle some problems, ready to get stressed for the next 2 to 3 hours, or depending how much we take or how do we feel. But I'm ready to, go to the depths of pain, of stress, and come back victorious. You get me? And how you doing, my guy? How you doing? You feel ready?
Yeah, I feel pretty good. Did some chores today. Cleaned up the
Yes,
room a
sir.
little bit.
Yes, sir.
Let's see, what else? I worked on our project. And then I think that was about it.
Okay, pretty chill then. Pretty chill. Pretty chill.
But I'm excited to get some problems done, and then hopefully get better with what's it called? With breadth first search.
Breadth versus BFS.
BFS.
Yes. That's the concentration. That's the concentration of today. We gonna tackle a little bit. We were wandering around that topic for the couple past streams, mentioning here and there, and today we decided to focus on some problems. Focus on BFS to see if we can learn, understand a little bit more, and yeah, I chose a problem, but Carlos is gonna be the one typing them. He's gonna be the one doing all the coding. I just be over here giving him some tips and tricks, maybe here and so. But yeah, I hope you guys enjoy the stream. We're gonna keep at it, and I'm good to go, my guy. I don't know about you.
I think I'm ready. Is there any announcements that you make or no?
No, hey, one more subscriber for 250. One more subscriber, and we're halfway there for a 500 sub goal, right? So we need one more subscriber. We also have the Discord link on the description or in the channel description. We have around 70 spots left. They're running out quick.
We got 70 spots.
Around 70 spots. They're running out. We don't want you guys to miss it, because if you miss it, you lose it. All right. So be there. Go in there as fast as you can. Click on it. Boom, boom, boom. Put your ideas there. Put your questions there and everything. And yeah, for sure.
All right. So the first problem. Oh. What was that? Oh.
Give me a second.
All right. Okay. So we're thinking the first problem is gonna be called same tree. So I'm gonna search that right now. This right here.
I'm sorry.
Okay, Jose's back. Jose's back.
Yeah, it's because my temporary desk here back home is next to the door, and my mom just came in, and but we're here though.
Oh, okay.
For sure.
So I was saying this is the first problem you want to do, right?
Yeah. That's
the same
first
tree.
problem we saw. Yes.
Oh.
Nope. Whoa.
Ignore that. So we mentioned earlier that we're trying to do some more breadth first search. I believe we already did depth first search, right? We've done.
Yeah, a little
like
bit.
a past
Yeah.
stream we've done. So last stream we did breadth first. We did a breadth first search problem, and it was new. It took us a while, so that's why we want to get back at it again, practice it again, and that's what we're gonna do um, for this problem. So whenever you're ready, Jose, I could read it, and then we could get it going.
No, I'll read it. I'll read it because you're gonna be the one typing here.
Okay,
So
do
I'll
your
read
thing.
it and you give the explanation, of course. So we have the problem number 100, same tree. It's an easy problem and it says the following: given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. For example, one, we're given the tree 1, 2, and 3, and and the tree 1, 2, and 3. Since they both have the same structure and values, they're both equal. They're equal. In example 2, we're given two trees. The first one has 1 and a left child of 2, and the other tree has a root of 1 and a right child of 2. Due to the fact they're not structurally identical, they are not the same. So I don't know if you can scroll down to number 3 over here. Yes, thank you, thank you. Here we have a tree, an example tree, example 3. We got one tree with the root 1, left child of 2, right child of 1. And then we got another tree with root 1, left child of 1, and right child of 2. Right? They're structurally identical, right? But the values differ, which cause the tree to be not the same, right? So therefore, the output is false. This is yes.
All right. So I'm thinking,
Mm-hmm, mm-hmm.
couldn't wouldn't this one be better for depth first search?
Ooh, depth first search.
Because like you could do
Mm.
the whatever order traversal order you would like to do, and just compare if they're
Mm-hmm,
both the same or not. But I guess it would work
mm-hmm,
the same way, right? If
mm-hmm.
you do breadth first search. But I was just thinking of that.
I was I was thinking a breadth first search, right? Because I think you can do them both, right? But since since this is the focus of like the breath, right? Breath, I think we should approach that breath, but it's mentioned in both topics,
Okay.
right? Both methods. Um, but here, this one, I was thinking we can create an algorithm, right? Or do the breadth first search and put all the values into an array, and then check if like all the children, all the roots into an array, right? Of both trees, and then we can check if both arrays are the same.
Okay.
If that makes sense, I don't know. Maybe.
Yeah. How about this?
Uh huh. Uh
To
huh.
make it that would definitely work. But to make it more difficult, would you want
No
to do
array.
it? Would you want to do no array and
Mm.
just have it where it starts at one tree? It starts at that root, and at the other tree it starts at that root, and you're both traversing at the same time doing the BFS
Mhm,
search.
mhm, mhm.
And then once it finds a false, then you just return false.
Oh, that'd be hard though. Hmm.
Really, you think
That'd
so?
be hard. I, well, to me, to my knowledge, I think so. I think so. I think so. Yeah.
Because you could um because I there was a problem called merge binary
Uh huh.
trees,
Uh huh.
and um it did the same concept where you start at both trees and
Mhm.
then you traverse the same way,
Mhm.
and you call the way you called the function was like for example BFS, and then it would be the P is the first tree. It'll be P left, and then the other one was Q left, which is the second tree. And let me see. It'll be root dot left equals B something like that, where it
Okay.
works the same way as the binary search as breadth first search,
Yep.
but
Yep.
this time you're I'm trying to remember, you're traversing both trees at the
Mhm.
same time. So if
Mhm.
you're going left on the other tree, you're going left on the second tree.
Mhm. Mhm. Mhm.
But I was just saying if you want to make it harder, but that would work. What you said is to compare the
No,
arrays.
we could do it like that. We can do it like that. Um. Yeah, I think so. I think we can do it like that. I'm down. I'm down. I'm down. Yeah, for sure. For sure.
Okay.
I think I
Ali
got.
with the hello.
Hey,
What's up?
aside too. Welcome
What's up?
to the
What's up?
stream, Ali. Welcome to the stream. Hey, she's an OG. She's been here every
OG.
stream. Yes, sir.
Hey, we might need to
Hey,
get some moderators pretty soon. You
yeah,
never
we
know.
might to get some moderators. Yeah,
Uh-huh.
yeah, yeah. Hey, so join the Discord. You might become moderator of chat and Discord. You never know. You never know.
Maybe, maybe.
Maybe, maybe. Alrighty.
What do you think? I
Okay.
don't know, cause I remember that's how like um,
Yeah.
what's it
I
called?
think. Mm,
Like the solutions. If you look at
yeah.
the
Yeah. Yeah. Yeah.
solutions, it showed that way to merge it.
Mm, I think it's possible, but I've never done it before. I'm curious to explore that idea. So I'm down to do it and see where it go. But I do have to like get a visual first to see how everything's gonna work.
I like the array approach. How about let's try that one first?
Hmm. Bro. All right. Oh, but you left me now with the itch, bro.
Uh,
Like the what if, bro. The what if.
because I'm thinking like binary a breadth first search.
Uh huh.
I'm thinking of it as depth first search on doing that way
Hmm.
that I was just saying. But
Okay. 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 I see. I see.
so
I
I
see. I
wanted
see.
to
I mean.
stick with
Uh huh.
because the way when I was just telling you that idea that I saw in the previous
Mhm.
problem
Mhm.
that I did, which I didn't solve like by myself. I had to like search it. I was dealing with it for like a while, and I didn't know how to
Mhm.
merge them. I was like, okay, well, you
Yeah.
can't
Yeah.
just do your normal breadth first search on it. Yeah, you cleared. There was clearly something else that I was missing.
Yeah. Yeah. Yeah.
Anyway,
Yeah.
so that was what they did. Is they did it at the same time,
Uh
and they did it
huh.
all in
Okay.
one function. And I was like, that's really nice. And that was one of the way. That's how they traversed through it. And they said like the root dot left equals the call, which is the self. Um, I can't type. Self dot is same tree, and then they just called. Um, it was
P and
like
Q.
if
Oh.
p then yeah. Oh, another thing that they did was they did a if statement inside
Inside
of
a
your function
damn like
call.
a parameter.
Yeah.
Damn.
So if
That's
I don't, I think it was written like this. If p, then you're gonna you're gonna say p dot left, something like that. Else, and then you're gonna say like you put in none because one of the base cases was if p and q. Oh,
uh-huh.
if not p and not q, then return none. And so then it would know, okay, there's nothing there anymore. In
G
this
G.
case, we could put, we could do that. And also, if this doesn't pass, then we could say if P and not Q, meaning like there's nothing on Q, but there's something on P, then that means they're different.
I was thinking the same thing. Like we can traverse, but we had to pick. We have to put like different base cases.
Yeah.
You get me? But we can do that. We can, and if you want, we can do a breath first because I feel like a breath first would be more easier, right?
Breadth first or depth first?
Breath.
Okay. So that's
Yeah.
that's the Q's and stuff.
Yeah. Yep.
Okay.
Yep. 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 Wait. Let me see. Yes, I
The
think so.
one where
Yeah.
you
Yeah.
have a
Yeah. Yeah.
visited and a Q
Yeah.
and
Yeah. Yeah.
then
Yeah.
yeah. Okay.
Okay. Alrighty. So you want to dry it out, or so
Draw it out. What
get
do you
like
mean?
an escalator jar or something to
Yeah,
get like
okay.
a good foundation
Yeah.
of this thing? You want me to get the link? I got you, my guy.
Oh yeah. Send me the link. Send me the link.
Yes, sir.
Ah.
Oh my god.
All right.
Oh
Fix
my
it.
god. Let me see. I'm gonna send it through DM again. Yes, sir. Alright, I got you. Should be good to go.
Okay.
Yeah.
Was
You got
this
it?
from a previous one?
Oh yes, yes, maybe.
I could delete.
Yeah, delete everything, delete everything. Yeah, this was from a
How do you?
past stream. Let me see. I got you. Wait, I think so.
All
There
right.
we go. Alrighty.
Okay.
Okay.
Orcus, what's up, bud?
Hey, Orcas in the stream. Welcome back, my guy. How you been? How's everything?
Okay. So,
Alrighty.
well, how did the tree look like?
I think it's one, two. Oh,
Sorry, Jose.
there you go. Yeah, no worries. You do you. You do you.
Okay. So then, now what? What do you need?
Okay, no, I'm good. I'm good. I have everything. I have everything.
Okay.
So you said you want to do breath first, right? Or
Yeah.
you want to do a breath first approach? Alrighty.
Yes.
So we start first. P. Okay.
I wish I had a pencil.
We okay. So, how would you approach this though? Hey, we've been good, or good? We've been good, thankfully. Thank God, we've been good.
Q.
Um.
All right.
mm, mm.
So this is how what I remember from the solution. So we start. Let me see. We
Uh-huh.
start at the roots of both.
Yep.
This one's P.
Uh-huh.
This one's Q. Right.
Mm-hmm.
Then you see. Then you add. Huh. Okay. If we're doing breadth first search, you gotta add those to a queue.
We can
Hmm.
have both. We can have Q1, Q2, right? And we'd be like, all right, one. So here would put one in here, right? And one in here. This is gonna be one. This is gonna be two, right?
Oh, okay.
And
So
then
two different queues.
yeah, and
Okay.
then we're gonna put visited. I think we'll do one and two, and then we're gonna do one since we already visited one, and this is gonna be on a. Is you want to do recursive
Well, with breadth first search,
or
isn't that you? We didn't learn how to do that recursively, right? We just learned
yeah,
how to do the while loop.
yeah. So you want to do while? So
Orcus,
while
yeah, we're thinking of doing that, but and that's what I was saying that with this problem it was like easier with just a pre-order, but we got these problems so that we could do breadth first search. We could practice that. So we're
yes.
just ignoring the depth first search solution to it.
Yeah. So if you see you guys struggling, it's because we put
And
this
we're
on
doing.
easy.
That's what I was saying. I said the idea because I thought it was cool. We could do two different routes, traverse at the same time. But now that I'm thinking about it, like we're just making it way harder. Let's just do what
Yeah.
you said.
You wanna
Just do breadth first
do
search on both of them,
uh-huh.
and then just compare the things.
All right. Fair enough. Okay.
So we'll create another
So
function, and then we'll
okay, let
do.
me
You know
delete
what
all
I'm saying?
this then. Yep. So we create a function. Let's call it breadth first search,
Yeah.
right? Which gets a root,
Mm-hmm.
gets a root. Um. Okay.
Well, I just
So
realized, Orcus, are you in school? I don't know if you're in school or not, but I don't know. We see you all the time, but I never asked you like about you. Like, who are you? How are you doing? What you've been doing? What's your goal right now? I'm just curious. I see you all the time. We really enjoy you always viewing, so I think it'll be cool to learn a little
to
bit
know
more.
to know who's viewing.
Yeah,
Yes, sir. Hey, he's an OG too, bro. He's an OG.
yeah, that's an OG. All right. Okay, keep
Alrighty.
going.
So we're gonna return a list right here, right? Where we're gonna have a queue.
Hello, hello.
Oh,
You're
Orc is
going to
going to
work.
work. Damn.
You're going to work. Like right now, or that's like I don't know what you mean by that.
Okay. So we're gonna go. Uh.
The visited and the queues are outside of the function.
Mm, uh. I would say to keep them in here because we're not gonna use the same
Oh,
queue and the
we're
same
not
visited
doing.
for each.
Oh, okay. I
You
see
get
what you're
me?
saying. Yeah,
Yeah, and then we're gonna return a list of all the nodes that we have.
yeah.
You get me?
Cool.
I mean, I don't know. Maybe there's a easier
No,
approach.
no,
So
no, my bad. That was a
we're, yeah,
misunderstanding.
we're gonna go nodes here. Yeah, good, my guy. It's gonna be a list. Sir, yes, sir. All right, so we got a queue visitor. So in queue, we're gonna dot append. We're gonna dot append root,
Mm-hmm.
right? And then we're gonna do
Well.
while queue, right?
Mm-hmm.
While queue.
Well, the
So we're
length of
gonna
queue, right?
well, cause queue is gonna run out. It's gonna run out of things. Cause we're gonna pop each of them. You get me?
Okay.
Yeah.
Orcus is
Cause here,
23.
Michael Jordan, bro.
Michael Jordan
Michael
year.
Jordan. Alrighty. So, mm, so while queue, right? We're gonna so if we're in queue and we wanna append, we're actually gonna do visited here. All right. If you're getting confused by that, tell me, because I'm also I'm wandering around
Well,
the stuff too.
I memorized the the code that we used in the last stream.
Really?
Mm-hmm.
Go for it, my guy. Take over if you want, my guy.
Okay.
Because right here I'm just wondering stuff.
So, I mean, I'm not saying what you're gonna do is wrong, but I
No, yeah, for sure.
memorized how. Let me see if I remember everything exactly. But so I didn't
Orcas
have. It was
from
like
July
this.
1st.
Huh?
Oh, from Orcas July 1st, I'm gonna go to work because I finished college last month. Hey, congratulations,
There
my
you
guy.
go. There you go.
Congratulations. Too easy, my boy. Too easy. Too easy.
Nice. Good stuff. So then it's like if root. Can I do this? Can I type this out? Do you think that's better?
Well, yep. Yeah.
Okay, type this out real quick.
Hey, Orcas with the internship. Woo. Well, Orcas
So
he's living the life.
bang. if root equals none, something like this, return.
Where are you typing it? Oh,
Oh,
here.
do you see?
Yes, but let me switch the color to
No,
something.
I'm typing it on the
Oh, on the LeetCode.
yeah.
Oh, okay, my bad.
Okay.
Okay.
So you wanted to do a function, which I
Uh-huh.
would agree to that. So def bfs root, and
Mm-hmm.
then you wanted to return a
Yeah.
list. You said
A list, yeah.
okay. So then we
Tap that.
do
Yes,
like
sir. Yes,
this,
sir.
return
Ooh.
list like that. Now that you know that root is
Ah.
not empty, then you append q
Ooh.
dot append
Okay.
root to the queue.
Mm-hmm.
From there, you do while, and like I said, I remember it. I remember it. So
Yeah.
length
No worries. No worries.
q, and then I think it was greater than 0. So while this is greater than 0, then that's when node is going to equal the q dot pop at 0.
Mm-hmm.
From
Zero, which
there,
is
you're going to check to
uh-huh.
see if the length of visited is less than equal to 1. If it is, then visited dot append node, no, dot append empty. Okay.
Okay. Oh, okay.
Yeah.
I see. Okay.
And then
You're
from
doing
there,
the
what's up?
okay. Okay. You're doing the okay, I see. I was thinking to instead of like you know how on the, I know which one you're talking about.
That's the one that what was their name?
Yeah, on Q.append, I think you have to append level. If I'm not mistaken.
It was this one right
On
here. It
18?
was Q level dot append no dot val. It was after that.
Wait.
And then you call
But on line 18, don't you have to put a tuple too? Like root,
oh
then level
yes, yes,
0?
yes, yes, yes.
Yeah.
So then you have level equals 0,
Uh-huh.
and then you do root level, and
Uh-huh.
then you have level right here, less
Uh-huh.
than level. There it is. Less
Okay,
than
okay.
level.
Okay.
And then trying to remember after that one, after you
Okay, you
append.
check you you appended to if you first check if left child, right child, I think. If left and right child exist, if they do, you append it
Yeah.
to the
If
to do that, and then you do plus level plus one.
exactly. Yeah, yeah,
Yeah.
perfect, perfect. Trying to remember, it was short. I did a shorthand. If root dot left.
Mm-hmm.
Um,
To Q level dot append
uh,
tuple.
wait, wait, how did I say it? Oh, node. And we're in node.
Mm-hmm.
So if node dot left, then I'm just gonna.
Uh,
I know it's exactly what you said. You're gonna have to
yep.
tuple this, so it's gonna be
Yeah, I
um,
think, but here I think instead of node, it's root because we're
root.
working with the root. Yeah. But if you to make it easier, you switch on the PFS on top on the function description, function declaration. Just switch it to node.
This.
Yeah.
Well, node.
Or
Well, node is this right here,
oh,
which
okay.
is gonna.
Never mind. Okay. Yeah. My bad.
Let me see.
Yeah.
Let me think.
Yeah,
Let me
but you
think.
said if left side is found, you append it
Yeah.
to to the level, right?
If
To the level, like you
node.
said. Is it to the level?
You
Yeah, I think you append it to the level. If node
you
dot
append
left.
it to the queue. You append the node to the queue,
Mm-hmm.
and then you add the level plus 1.
Yeah. Yep.
So if node dot left, then you do q dot append, and then you're gonna add the node, and then you're gonna do level +1, something like that,
Okay.
right?
Yeah. Yep. Yeah.
And then if node dot right, and then q dot append. Oh wait, is it node dot left, right?
Yeah. Mm-hmm.
Right, +1, something like that.
So, you want me to double check?
No, we could test it. We could test it. So then once we're done with this, then we return list, right?
Uh-huh.
Return not list. You return visited.
Yep. I
Now you
like it. I
say
like it.
if BFS P equals BFS Q,
Mm.
return,
Wait. Visit it?
right?
Is it visit it?
That's
Oh
the
yes.
final.
Yes. Yep. You're good.
Okay, and
Mhm.
then return true. I don't know if this is gonna work. By the way, I'm just
Yep. No,
else
just
return false, something like
false.
that.
Yep. Run it.
I'm scared.
Hey, we're running it. We're submitting it.
Okay, where are we at?
928.
Q level dot append node.
Q level.
That means I missed something because I ran through. I
Mhm.
encountered this as well.
Oh, it's because
Doing
you're
some.
doing Q. I think it's visited. Because you're appending
Yeah,
into the queue.
yeah, I think you're
Yeah,
right.
there we go. Mm-hmm.
Okay. Now let's see.
Ooh, you see, okay, right here, I see the problem here. Okay, since um what was I gonna say? Since two are in the same level, right? It's gonna put them like on the same array. You get me? So that's why it's not gonna differentiate which one is which, if that makes sense.
No, I think the problem is we're not putting in null into the array, right?
Yeah, I was gonna say we have to put null into there. So if you say if root equals null or if root equals none,
Which is this. If no
yeah,
dot left, else, then you're gonna put um. I want
you're
to
gonna
learn how to.
append
What's the
it.
shorthand? You're gonna pen null,
Yeah,
right?
yeah.
Uh, in the queue
In is it in the visitor?
because if it's null, then that means it goes
Mm-hmm. Think it's
back
in the
up here.
visitor, no?
I would think so too.
Yeah, and you just put Q that append um um, 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 um. So you do the
Visited
visited. Uh-huh.
level dot append um none.
Uh-huh.
Some, something like that.
Yeah, it's outlive. Oh no, it's else. Never mind. Damn, today's not my day, bro.
Right? Don't you think that right? This is the right spot?
I feel like that's the right spot, but I'm think no, yeah, that's the right spot. Yeah, for sure. Try running it. Okay. print out the visited. Let's see what's. Just do print BFS P.
Oh,
Yeah,
you just all you have to do is just do that.
yeah. Uh-huh.
Oh, I want to click that.
It's starting, bro. Okay. That's good. Go to the number 2. That's good too.
No, this one should say.
That should say false. Mm. You see, I was thinking instead of doing levels, let's just put them all in order as we like instead of putting like a array instead of array, right? Why not just like put them all in order, right? Without knowing what level it is. You get
Okay.
me?
Yeah.
Yeah. So there'll be some like and then we do length of queue. We remove level. Then I think we remove the that if statement and the visited. Yeah, yeah. Uh huh. Then we and we remove the tuples. Yeah, the parentheses. There you go. Uh huh. There we go. And that should give you something similar to that.
If no dot left. So let's say this one right here.
Mm-hmm.
If it goes to left. Well, if it's none, then it
It's
goes to
gonna
else. So
it's gonna
visit
append
dot
none.
append none.
Uh-huh. If not, it goes to q dot append right.
No dot right.
Mm-hmm.
It
Then it
does.
goes on the loop.
Then it does a loop.
Oops.
The length of the queue is updated, right? So now, like,
It's 1. So
you
we
want
appended the q.
and
We
okay,
appended the right. Then the
pops
2 is
to
gonna go. It's gonna add
okay.
2.
You want to run it?
Uh-huh. Yeah, run it. Mm-hmm. Mm. Let's see. 1. Yeah, it's gonna. We had something similar to this before. We had like a similar problem to this, where where one, which one is P? P is left side, right? Left.
Yeah.
Mm-hmm. Mm. So we do 1, gets appended, and then we go to left shout, gets appended, then we get right shout. Mm, I think that's I think that's it because on 1, right? We go to left, we append the Q, right? Right, since 2 exists, right? So we're in the first on the first if statement, no dot left, right? Since 1 has a 2, it gets appended, right? On line 31, right there. Line 31, it gets appended, right? And then we go to the other if. The other if checks the right. Since it's no, it gets added to the visited. You get me? So we have to skip that part in there. So
Wait.
you get me?
No. Well, I'm confused because this right here,
Uh huh.
it's saying the node it's at is one, the node
Uh
to the
huh.
left is none.
You see, that's a problem,
Why?
because
And I'm trying to figure out
because
why. Did you just
you know
explain
that
why?
yes, yes, yes.
Okay.
Explain. Go down, go down, go down, go down a little bit. So there we go. Okay, so one, right?
Where are
We
we
go to
at?
one,
What
one.
line?
Let's start at the while loop.
Okay.
21.
Okay.
One, right?
The length
It's
is
already
one.
queued in. Yeah, one, right? We pop it, right?
Okay. So it's
So
one.
visit it dot append. So now visit it has one, right?
Yes.
Then we check left. Does left have something?
Yes.
Yes. So it gets appended to the queue, right?
Okay.
But guess what? We still have this other if over here on the bottom, right? Note that right, it doesn't have nothing, right? So we don't append it to queue. Therefore, we go to the else and
Oh.
we append the zero.
Yeah.
You get me?
Yeah.
So that's where we have the trouble. So I was thinking we can use the keyword continue, right? As soon as we mm, let's say we hit visited.append. Wait, no. Um, I'm thinking.
I just honestly, I think we don't need these. I think
Uh,
it'll look.
go
Look.
for it. Go for it.
Let's see. Let's
Yeah,
see.
yeah. Let's see. Let's see. Let's see. Okay. Uh, Give
Okay.
me
We
one
do.
and two. We do
Okay.
need them because we need to fill in the zeros.
If
Because we are just adding all the elements. We're not specifying what level they are or what order are they in, right?
let me see this again.
So that's why if we hit a two, right? As soon as we hit like a node, we continue to the next iteration because we don't want to go to the right side, right? And then, well, we do want to go check if it's a right side. Ooh, hmm. This is an interesting dilemma. Very interesting. Calm down, my boy. Calm down, my
I'm
boy. Calm
sorry.
down, my boy.
It's,
Calm
you know
down.
what bothers me?
Uh huh.
You know what bothers me
Hmm.
is that we could solve this problem with
Oh
just
yeah,
for
we can.
search.
Can
But
we?
yes,
Oh yeah,
that
yeah, yeah, yeah.
for like
With pre-order traversal.
pre-order, post-order, in order, don't matter. At least I think it doesn't matter. They're so. Anyways,
Yeah.
it's just annoying me that I decided that we should do breadth for search on
I
this
mean,
dumb problem.
it's 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 we just have to figure out
Hold me back.
when to add that zero. That's where we have to figure it out. That's the only thing. Alrighty. Apart from that, we're good. We're good, bro. Calm down, bro. I got this. We got
Hold
this,
me
bro. I'm gonna
back,
hold you
man.
back. I'm gonna hold you back, my guy. I'm gonna hold you
So
back.
we go one, two, and then it checks the right. We need to check the
So
right.
we
That's
have to check the
it's
right.
breadth
Yeah.
first search.
Uh huh. Uh huh.
So it's one, and then the next one's gonna be two and null, and then the next
So
one.
two,
We
right?
need
We
the
do a level
arrays.
pen.
We need the level order.
Either way, if we have the level order, we're still gonna have the same thing. Because in the level order, we still have to add that zero, or you still have to add that null component. Because it's just gonna give us the number or the values that are in that level. For example, on three, it's gonna give us two, one, one, two, right? It's not gonna give us or two, no, low, then no, two. You get me? We still have to figure out that idea. And I feel this way is easier because we don't have to worry about the levels. We just have to worry about the structure of the array. You get me?
So, could you explain how it needs to look again in the output? It needs to say
To
one, two,
one,
null.
two, no,
The other one
yes,
needs to
and the other
say
one says
one, null,
one,
two.
no, two. Exactly, 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 exactly. So here, I feel like we just
One, two. No.
Mm-hmm. I'm thinking. I'm thinking. I'm also thinking, my guy. I'm thinking right now. You're not alone. You're not alone. Uh, I don't think. I don't think that's gonna work, my guy.
Do we need this? We didn't update
Yes, we have to
this.
check. We have to check.
But that's gonna put it into an array. We need we
Yeah.
don't need that, right? We need the
I
base
don't
case,
think.
but I'm just saying we
Mhm.
don't need it to
No, the
return an
rate. Yeah,
array.
yeah, yeah. Uh-huh. Um, think about it. So let's work it out. Let's work it out. Go to one, right? Then we go to left. If left is if left is okay, so we can add to the queue, right? Those zeros or that none, right? Q dot append none. Say if uh if node equals none, right? We
Mm-hmm.
add 0 to the visited, right? And then we continue to the next iteration. So let's say on number right here on 24 on 24 right there. Yeah, you're gonna do an if statement right there. And say if node, right? If no if equals none, yeah. Okay. You're gonna do visited dot append none, and then we're gonna continue. There you go. I feel that would work. You get me? No, maybe, maybe so. Bro,
um,
what you laughing, my boy? What you laughing, bro?
it's in the queue.
Uh-huh.
It's gonna check. It's gonna pop the null.
Mm-hmm.
If node is if node is none,
Uh-huh. So if none is none, we're gonna on the visited, right, which is where we're gonna return, we're gonna add a none, right? So now we are
and then continue,
append
meaning don't do any
you
of this.
it do, and go to the next iteration, which is gonna pop, right? We're just gonna start from the line 21 from the top, right? I don't know if that's gonna work though.
Continue.
Yeah, continue means like stop there and continue to the next iteration. Like don't do anything else. But I don't know if that's gonna work though. Mm, yep. I don't know if it's gonna work. I'm doubting myself now.
Oh,
Oh, oh, oh, oh, oh,
one, two,
oh,
none.
oh, alrighty. Autopilot.
One, none, two,
Oh,
none, none.
should work now.
Something like that.
Yep. Ooh, 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 baby. Sir, sir.
All right.
Yes, sir. Let's see. Give me one
With
second, my
just
guy.
with just one in there, it does the correct output, and then with
Uh-huh.
nothing in there. Oh, wait.
Toss.
Uh. Oh.
Ooh, we have to
Mm,
check the values.
what do you mean?
Ooh, that's all right. Never mind. Never mind. Never mind. We good. We good. We good.
All right.
Come on, my
You
boy.
think so?
Come on, my
You
boy.
think we can
Come on, my
submit
boy.
it?
Come on. Come on. Come on. Come on. Come on. Ah! Wow. Let's
Good
go.
stuff.
Let's go. Let's go. Let's go. Hey, now we learned something new, bro. Now we learned something new.
I'm
That
upset
every time we figure we need that zero, just add it in there, and if it is, just boom, bro. Why are you upset, my guy? Why are you upset, my guy?
because I'm just mad.
No, don't be mad, bro. Be happy. Life is beautiful. Life is beautiful. Hey, thank you, Orcus. Thank you, Orcus. Thank you, thank you, thank you. Ooh, ooh. Isn't there if something even better? They're called tertiary Python. Let me see. Ternary Python.
Does
Yeah.
this work?
No. It has to be before. It has to be q dot append node left if node left. Else. So you're gonna move the if node dot left in front of. There we go. And remove the colon. Yeah. And the else colon. No. Yeah. Remove the else. Yeah. Something like that.
So like this.
Yep. Yep. Mm-hmm. Uh huh. Yes, sir.
Life is beautiful.
But that reminds me, I don't know if you remember compound sentences with the if and stuff, where if you have a, no, is it complex sentences? Where if you have the if in the middle, you have to put the comma, like you don't put the comma, but if you have it in the front, you move a comma. So it's something weird like that. That reminds me of that. Good old days, good old days.
I just scared myself. Did you see what I
Hey,
put?
bro. Nah.
I changed it, like trying to like make it look more clean, and then just three test cases were wrong. I got scared for a second.
Nah, bro. Hey, first
All right,
one done, bro. Let's go. Let's
all
go.
right, good stuff.
Too easy.
You want ready for the next one?
Hey, bro, we have to explain it, bro.
Okay,
You're rushing, you're rushing.
all right. Am I explaining?
Yes, sir.
All right. Let me take out my gum. All right. So for this problem, we have same tree, and you want to check the nodes of the tree. We're going to do BFS, so by breadth first search. We're going to do level order, so that means we're going to start from the top one, check that level, which is 0, and then you check the second level, which is 2 and 3. And if there was more, you would check that number all the way across, like horizontally. So
Yes, sir.
if you, for example, 1, if you do horizontal checking, 1 and 1 is the same. 2 and 3 and 2 and 3 is the same. So that means this is true. If you go on the next one, you have 1 and 1, that's the same. Go on the next one, 2 and nothing, which is none. That's how this tree is. And then the other one is none and 2, which is not the same. So that means that's false. Since you're doing level order, you're checking horizontally. So lastly, we have another one. You're doing 1 and 1. Those both are the same. The next one, you're doing 2 and 1. Is that the same as 1 and 2? No, it's not. So you return false. How that's done in the code is you do BFS, which is using queues and a visited array. And the base case for that is if root is none, then you return you just return, and then you want to append the initial root to the queue. So once you have the initial root in the queue, you're gonna check the length of the queue is greater than 0, and then you're gonna just pop that node from the queue. So now technically the queue is empty. Before it had the root, now it's empty. With it empty and the value of the node equal to the value of the root equal to node, then that means we're going to be checking node, and we're going to see if node is null. Then this one gets complicated. Hold up. I'm going to skip this part because this one's not applicable right now. So anyways, you keep, since the queue, you just pop the value, and now you have the value of, let's say for this example, you have 1. You have the value of 1. So in our visited, which is our final array, you're going to pin the value of 1 to visited. So now technically we have 1 in here. And now the queue is empty so far until we add more. So that's what this line does, is it adds more to the queue if there's more nodes to traverse to. So you check node.left of the current node that we got from here. And from this example, there is another node. It's 2. So then you add 2 to the queue. So now the queue has 2. And then you're going to check if there's a node on the right side. So is there a node on the right side of 1? Yes, there is. It's 3. So then you add the node 3 to there. And then you loop again. So the length of the queue is now 2, 1, 2. And then you're going to pop the first thing, which is 2. So you get 2 out of there. Now node equals 2, or the node 2. And then if the node is none, which is not, you're going to keep going. You append the visited node to there, so you do 2, and then you keep going, keep going, keep going. Where this is applicable is, let's say you're on example 2 and you do node.left. So for this tree right here, if you look on the left side, there's nothing there. So if node.left, if it's none, meaning there's nothing there, then you append none to the queue. So now let's just say none is in there. So the next time you iterate, you're going to pop none out of there. So none gone. And now you're saying if node is none, which it is because it just popped none from the queue, then you're going to append none to the visited. So now the visited would be none. And then you continue. So you ignore all this stuff right here. You ignore and you go to the next iteration to see if the condition still applies. So that's why you have this like base case in a way, right? It's considered a base case, I guess.
Yeah,
Kind
you
of,
can say so.
kind
Yeah.
of, not really, but
Mhm.
I guess.
This is more like a catch case, like you
Yeah,
catch something. That's maybe I don't know if that's a term or something, but I consider like more like a catch.
I guess
You know
base
what I mean?
case would be more so with recursion, right?
Yeah. Yep. Yep. Yeah.
Yeah. So, anyways, that's kind of the basic of it. And then lastly, you return the visit array, which has the total level order traversal nodes. So if we just fast forward and we're back on example 1, the visit array would look 1, 2, comma 3. It would look like this. So you return that, and then what this does is it calls both functions for the tree P and the tree Q. So this one would return um, the array 1, 2, 3. And then if you do Q, which is this one right here, it would do the same thing. It'll do 1, 2, 3. Since those two equal each other, it returns true. And if they don't, it returns false. So that's what that is. All right.
Yes, sir. Pretty much. Hey, bro, you explained it pretty nice, bro. Better than me. Better than me.
Oh, my breath. I was running out of breath, man. All right, we
Hey, you
got
got
that
it too,
done.
then.
Let's do the dude. I don't know why you chose this one. I've seen it when I was doing some LeetCode, and I've never done it because of how much people don't like it.
All
It's
right, check. Huh?
the minimum depth of binary tree. And if you
Oof.
look at the acceptance rate, Less than
It's like
50%.
40.
One of
I
the
check
worst problems. What's up?
check Petsum. Petsum, check if you which one of those do you like better?
Well, there's actually another one of this one. I'm sure it'll say right here. It's the maximum depth of a binary tree.
Uh-huh.
That
Uh-huh.
that one is more friendly, if you will.
All right, let's do that one. Let's do that one
Okay.
then. Yes, sir.
Okay. You need me to read it? So
Uh,
I'm gonna be real with you.
uh-huh.
I've done this one.
Ooh.
So I feel like I should read it
And I'll
and
do the
let you do it.
okay. All right. Fair enough. Fair enough. All
Okay.
right. Let's go. Let's go.
So for this problem, 104, maximum depth of binary tree. You're given a root of a binary tree. Return the maximum depth. Depth. The binary
Depth.
tree's maximum depth is number of nodes along the longest path from the root node down to the furthest leaf node. So the root node, which is 3, to the furthest leaf node, which means it has no children, which this one's a leaf node, this one's a leaf node, this one's a leaf node. This one is not the furthest though, so you keep going.
Yep.
This one's the furthest. This one's technically the furthest. So this would be the max depth right here. It would be 1, 2, 3 if you're doing level order. So this level right here is 1. This level right here is 2. This level right here is 3. And then I guess they don't give you a picture for example 2, so I'm not gonna worry about that one.
Yep.
Anyways,
I get you. Get you.
do your
Ooh.
thing.
Okay. Okay. Let me see. Let me think about it.
Think of me like
I'm thinking
like
about
GitHub
breath.
Copilot. I'm GitHub Copilot, right?
Good. Alrighty. I feel like the breadth first search would be a good idea.
No, you need to do it in
Right?
breadth first search. That's
Yeah,
a
breadth
requirement.
first search. Oh, they require.
I'm
Okay, I see.
requiring you to do it in breadth
Oh, I
first
see.
search.
Okay.
The question isn't,
Okay.
but I'm requiring
Yeah.
you.
Okay.
Yeah.
Um, gonna check the furthest the path, right?
Yeah.
Down to the furthest leaf node.
Yep.
I mean, can we use the code that we were gonna use the other time for the previous problem where we were gonna do levels, right? And just get the size of the array.
You're brilliant, man. That's actually
Yeah.
that's actually a coach recommendation approach.
A coach recommendation
As your
approach?
coach, as your coach for this problem, I totally recommend you doing that.
Alrighty.
Yes.
Okay. Let's do it then. All
All
right.
right.
I'm gonna try and remember. I haven't memorized it, right? I haven't really looked at the code to try to memorize it, so I might need some help here. All right.
I'm here. I'm here with you. I'm here
All
with
right.
you.
Okay. So we need a queue.
Okay.
Queue. Oh, all right. We're gonna. Can we do it? Because I was thinking of a function. We can make a function. Yeah. Let's make it a function. So it could be easier. Call it BFS. And we're gonna put a root. Yes, sir. We're gonna return a list.
Okay.
Yeah, and we're gonna say q equals empty list.
Oh, dude,
List.
I'm actually embarrassed. You know why? We haven't changed our levels, man.
Bro, actually, dude, I was thinking of the same thing, bro, but it slipped my mind.
The
Let's go.
disrespect. Hold up.
Come
The
back.
disrespect.
Let's go
Hold
to
on.
the street. Let's go to
All
the
right, we're
street.
here. We're here.
All
Quick,
right.
quick intermission. Sorry, we had to interrupt.
No worries.
We
no
gotta.
worries. Y'all get it.
This is a priority of ours. We gotta make sure we respect the game. Make
Respect
sure.
the game.
Wait, hold up. Okay. Make sure you respect the game. So what this is, we're just gonna give our level, how we feel mentally.
Yes, sir.
It's our insane level. So it varies from 0 to 10. Some days it goes all the way up to 100. You never know. But all right, you go first, Jose. I'm gonna give you.
I'm feeling like a 2. Like a 2.
You're feeling
Feeling
it too.
good. I'm feeling good. Feeling nice. But it slowly but surely started to creep in, bro. Like
Okay.
that mental fatigue. You know.
Okay.
But I'm good. I'm good at two. I'm solid two right now. Pretty chill, pretty
Um,
nice. You
you
know.
know,
Uh huh.
sorry to interrupt you. I don't know if you were done.
No worries. No, you good. You good. You do
You
you.
know, as someone who respects the game so much, I'd never want to cheat the game. So
Uh huh.
I would always want to give my authentic level each
Uh
time
huh.
we do these. So I'm gonna actually say like a 4.
Ooh.
My head,
Okay.
my head hurts a little bit after that first pop.
Okay. Okay. Okay.
Yeah.
Okay.
You could go for the viewers. You could go back and see maybe why I'm hurting from it, but I don't. I feel like I don't need to explain myself uh, on that number that I just gave. So
Hey, also, if you're in the chat and you're doing this with us, comment down your insane level. You know, we want to see well, how you doing? How you doing? Yo,
all right,
what's up, official pancake? Welcome to the stream, my guy. Welcome to the
Pancake, what's up,
stream.
bud?
Welcome to. Make sure to subscribe. What up, Eddie? How you
Hey,
doing, my boy? How
hey,
you
are we at
doing,
a
my
hundred?
guy?
Are we at 250 subs yet?
I think we're at 250 subs. Maybe let me refresh.
Eddie might be the
Maybe
250.
maybe Eddie might be the 250. Let's see. Let me see. Let me see. Let me check real quick. Yes, sir. We're at 250.
No, that's
Yes, sir.
either Eddie or
250.
that's either someone else.
Hmm.
Because
I
maybe
think
when
it's
Eddie
Eddie. I think it's
subscribes,
Eddie.
it'll be 151 or 251.
I don't
Mm.
know, but I think it's Eddie, my guy.
All right, we're back
I
at it.
mean, we're back at it. We're back at it. Yes, sir. But welcome to the stream. Alrighty.
All right, back to it.
So,
Sorry, quick intermission.
no, no worries. No worries. Um, Orcus hasn't done anything. It's at 0. Hey, that's good though. Have to be ready for work. By the end of work, you're gonna be by like 10 or something. But hopefully not. Hopefully not. Alrighty. So for this one, we're gonna do a queue empty list.
Okay.
And then we're gonna do visited empty list. And then we're gonna do level 0. Then we're gonna check if root is none. If root is none, if so, we return empty list, right? And then we do q.append root and level a tuple exactly. Then we're gonna go while root while q, right? Because as long as q has something, we're gonna do if the length of visited is less than or equal to level.
You really do got a photographic memory, do you?
Me? Nah, dude, not even my guy.
There's
Not
no
even my
way.
guy. Not even my guy.
I
No,
know.
no, no.
Nah, I caught you now. I know how you be
Me?
memorizing stuff because you got a photographic memory. Your
Nah, bro,
secret,
not
your secret is
even.
exposed.
Not even my guy. Not
I've
even.
been trying to figure out how does Jose remember
Uh
those
huh.
things. And am I doing something wrong? Which I'm sure I am. I'm also not probably putting as much work as Jose does. But that's another thing that you have is you just have a photographic memory that you can just remember
Nah,
stuff.
bro.
You could see it.
Nah.
How did you remember that it's less than equal to level?
I mean, because I remember, because the first time we saw this, I remember I was studying that thing, studying that if statement, and it just got stuck in my head.
Yeah, whatever.
Yeah,
I
nah,
caught you. I
bro.
caught you, bro.
Not even, bro. Jose
Anyways,
exposed. Nah. Okay, so if we're gonna do visited.append empty list,
oh man, you're making me mad.
and then we're gonna do let me think. I think it's visited level. No, yes, visited visited at level.append. We're gonna append. We have to pop node on top of if.
Ah, okay,
We have to
okay.
pop. We have to do node dot pop node q dot pop 0. Ooh. Okay, okay. Alrighty, and then we're gonna append node. Yes, sir.
Okay.
And then here we're gonna do it. Okay. Ooh, I'm gonna get fancy with this. I'm gonna get
Fancy.
fancy. I'm gonna get fancy. I'm gonna get fancy. Mm, wait. Never mind. No.
You're not gonna get
Wait.
fancy
Wait.
on
Wait. Wait.
this.
No. I think I'm gonna get fancy in here.
Okay.
Do uh Q dot append note dot left comma level plus one in a tuple. In a tuple. In a tuple.
Comma. Okay, okay.
In a tuple. In a tuple. Yeah, I think you have to delete that parentheses after left. Wait, huh? I'm confused. I think you have some extra parentheses in there. The Q, the one on the left, Q, erase that, yeah. And then you're gonna put one on node before node. And you're gonna put another one after one. Delete that one and then add one after one. Yeah, yeah. Then yeah, delete that one. And
Okay,
then
okay.
we're gonna do if node dot left. Ooh, ooh.
Okay, okay,
Okay, and
okay.
then copy all of that, paste it again, replace left with right,
Okay,
and then
okay.
after that, after the while loop, so go back one. There we go. Return visited. Then
Alright.
we're gonna go return length of visited. I think that's it. I think that's it.
Are you sure? I'm gonna I'm like a
Oh,
genie. I'm like a genie. I got
uh huh,
three little wishes.
uh huh.
Nah, I don't know what I'm saying. But I don't know if you're missing something. I see something you're missing. That's all I'm saying.
That level.
And I make the mistake too. It took me like 5 different problems and I still miss it. So I don't blame you. I don't blame you.
Is it a condition statement? Is it a syntax
Nope.
error?
Nope, not a syntax.
Logical?
Well, maybe there's a syntax error. I don't know if there's a syntax error.
Like a logical error? Like I'm
Mm,
missing some type of logic? Missing a step?
you're missing a variable.
Uh, variable? A node, you have to pick at the level 2.
Where?
A node, line 24.
You're correct.
Ah, bro, you're
It's
cheeky, bro. You're
sneaky.
cheeky.
It's
You're sneaky,
sneaky.
sneaky. Tricky, my guy.
It's sneaky,
Tricky,
man. I
tricky.
don't know. Sometimes it hides a little bit. I always forget it. But yeah, you got it right.
Yeesh.
I think
All
that's
right.
all. That's the only thing I saw. But like I said, I could miss some other things too. You never know.
Nah, you're good. You good. You good.
All right, you
Alrighty.
ready to run it?
Run it. Run it. Run it. Ooh. Oh, cause you need an else. Ah. Okay. Let's just do it regularly then. Regular. Where? Yeah. Uh huh. Uh huh. Eh. Guillermo Gonzalez, Jose stand up and do the Gangnam style. Ooh, bro. Damn. I don't, hey, if you join the Discord, I might. But you have to join the Discord. Join the Discord.
Like this?
Yes, sir. Yes, sir.
All
Yeah.
right.
Join the Discord memo. It's link in the description. Ooh.
Did I spell it wrong?
Oh no, because it's not defined on the outside. Put on list on top of the definition. Put instead of a list, put int. And over here on the bottom, with on the return visited, return length visited. And ooh,
We didn't even call it, right?
oh, we didn't even call it. That's so true. Okay. Um. Yeah, do
Oh, brother.
BFS root, BFS root.
Like
All right.
that.
So according to Orcus, for that kind of if statement, you need a statement as an if statement. So we need. So the one line if statement, you do need an if statement. So keep that in mind for as a
Alright.
reference. As a
Let me know when you
reference.
need me to run it.
Saka Discord link. It's in the description. Let me see if it's in the description. Yeah, it's in the description. It's in the description. Check out the description of the live stream.
I'm running it.
Oh, link in, bro. Yes,
There we
sir. We got
go.
it. We
Whoa,
got it.
whoa,
We got.
whoa. Whoa, hold your horses.
Then we
That
have to
was
submit
just
though. We have
running.
to submit. We have to submit.
One thing I'd like to check is I always like to check it because I've gotten
You have
this
like
this happened to
PTSD or
me so
something.
many times. Or not so many times, but I just like to check if those
Oh damn! What happened?
there's an error with an empty. Jose,
Yes, sir. Yes, sir.
you gotta fix something.
Go up, go up, go up, go up, go up, go up, go up.
There you go.
What is it? What is it?
I just put because I'm that's a test case, right? Just nothing.
Yeah.
And then it says not valid value for expected return type.
Or maybe because it's an empty list.
Yeah.
Um, go above instead of int return list. Yep, 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 yep. And then over here, return a visited. Hey Arturo, welcome to the stream. Welcome to
Damn,
the
the
stream.
whole family.
Hey, the whole friend group. Yes, sir. Yes,
What's up? What's
sir.
up?
Welcome to the stream.
Oh,
All right, go length BFS roots. Hopefully that works.
all right.
Oh, Orcus is saying to return 0. That might actually work. Oh, oh, ooh,
All
ooh,
right.
ooh,
Those
ooh.
are the only test cases I wanted to use. So, do you have any more in mind?
Nah, I'm good. I'm good. I'm good.
All right. Check it.
Yes, sir. Yes, sir. Yes, sir. Yes,
Good
sir.
stuff.
Ski. We in here. We in here.
Good stuff. I'm glad we
Yes,
caught that.
sir.
All right,
Hey,
Jose.
GG's, bro.
Explain it.
That was all right. So here we're doing a BFS algorithm, which means a breadth first. Can you go to the description?
Yeah.
There you go. Which means a breadth
I'll be right back while
breadth
you're doing that.
first. Yes, sir. Yes, sir. A breadth first search algorithm basically means that we're gonna read a tree level by level. If you don't know what that means, level means like there's a node on that level. For example, the first level is 3, right? The second level is 9 and 20, right? Because they're in the same line per se. Then the third level is 15 and 7 because they're in the same line. So in order to do this, right, we created a function that we have a queue and a visitor, right? And that level set to 0. Then we check if the root is none. This means that if we're given an empty tree, right, we are able to catch and just return an empty array, right? But if not, we append to the queue the root. In this case, is gonna be 3, right? Then we enter a while loop, and we're in this while loop we check if the queue still has something, right? And then the node level could then we get the node and level of the first element in the queue by popping it. Then we check if we have enough space in the visited to append, right? In this if statement, we check if length visited is less than or equal to level. This is basically going to check if we're in the right level, and if we're not, we're just going to give another array instead of an array, which is crazy, yeah, but it's going to help us manage the levels that we have and append those levels, append the values to the correct levels. So as soon as we have the right amount of levels, we go to visit it, we add the level, we append the node to the level we desire, right? As specified by line 28, and then we check if we have a left. If we have a left node, we do the same thing. We append it to the queue, right? And we increase the level. Why? Because we went one down. For example, 3, we go to the left, that's 9, that's level number 2, so we have to increase the level. Same thing for right. We have our right level, we increase the level by 1. Right after we do this a couple times, after we loop through the entire tree, we return visited, which is the all the levels ordered by all the tree ordered by level, right? That's what we return. Then we get the length of that visited and we return it. This is going to give us the amount of levels we have in the tree. In this case, we have 3 levels, right? And the third level, in this case, is the least or the maximum depth of the binary tree. So yeah, a little bit complicated, a little bit weird, but we went more in depth this on previous stream on Friday where we actually talk about it. We dissected this exact same code, right, in one of the problems. So it's pretty fun, pretty cool, pretty interesting. One of the viewers helped us out figure out this code. So it's really nice, really nice. This is yes.
Nice. Good stuff,
Yeah.
Jose. Good stuff.
Yes sir, yes sir.
All right, we're approaching our last problem.
The last problem. Hey, we are 251. 250. We broke
251.
halfway of the subscribers. 251.
We're almost at
Yes sir.
500 subs.
We're almost 500 subs.
Halfway
Hey, that's
there.
a goal for this summer. So make sure to subscribe, share, you know, share, like, comment, whatever you guys want. Just, of course, be here, be here. Hey, join the Discord. Limited spots. We're running out. We're running out.
Okay.
This
Oh, I forgot. Insane level. Insane level.
insane level. Yes, sir. Yes,
All right.
sir. All right.
Jose,
What's
would
it?
you
Oh,
like to?
well.
What's up?
Yep, yep, yep.
Would you like to go first?
Uh, yeah. Right now I'm feeling pretty good. I'm like at a 2, a 3, a 3, a 3, a
Okay.
3. I'm good. I'm good. Yeah, not too bad, not so much, right? I'm doing good, right? I'm scared of this problem, path some, the next problem, but right now I'm pretty good. I'm
All
pretty
right.
good, pretty good.
As for
How about you, my
me,
guy?
like I took a step back for this round, for this quarter, if you will. Um, so I actually decreased my level.
Ooh,
So
okay, okay,
I'm actually even with you now. I'm at a 3.
okay. A 3. All right,
Now,
all right. Yeah, we're in the same level. Pretty good, pretty good. Yes,
now
sir.
we'll, we'll see about this one. I have no
Alrighty.
clue
This
on.
one, me neither. Me neither.
I haven't done it, so uh, it says I was looking at the topics. It says depth first search. Oh, they can't see it. It says it right here. So I mean, breadth first search says it right there. So I mean,
But I feel like this a binary search would make this problem super easy, my guy. I don't know. I feel
does
like
it
it.
does it say that? Oh, binary tree. Yeah.
Binary search tree. But we'll see. 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 Alrighty. So let's see. Let's see. Let's see. So what approach? First we have to read the problem. Alrighty.
Yeah.
You want me to read it?
You can read it.
Okay, so we're here. We have problem 112, path sums, and it says the following: given the root of the binary tree and an integer target sum, return true if the tree has a root to leaf path such that adding up all the values along the path equals target sum. A leaf node is with no children. Is a node with no children. Example 1, we are given the target sum of 22, and we can achieve this by following the path 5, 4, 11, 2, which if you add them up equals 22. Example 2, we have target sum of 5. You cannot add any of these, right? Or there's no path that if you add the values of the path give you 5, so that's why it returns false. In example 3, empty array target sum 0. Of course, it's gonna be false because there's nothing in there. All right.
I already don't like it.
You don't like it? I think it's gonna be
Are
fun
we
though.
doing breadth first search, or we're trying to solve it however we want?
You tell me, bro. I require you. Ooh, it's a requirement.
Huh.
I'm gonna pull a reverse card on you.
Hmm.
So let's see. Let's think it through. Let's think it through.
Huh.
Because I feel like a binary search tree, right, where we go to left or right, could be good, or would be even better.
But how does that work at the bottom whenever it's 11? Like, how would you know to
Yeah.
go left when left is greater than? Oh,
Well,
wait.
that's the thing. If it's greater, we don't go 7. If we don't go to 7, we go to 2. But if that's also greater, there's no path. That's where we go left or right. But on a breadth search, hmm, hmm, not sure. I'm not really sure. Breadth search.
I think we gotta not do breadth for search on this one.
Are you sure?
Yeah.
Positive?
I don't.
Okay.
I'm trying to think how that would work if you're doing level order, and that level order doesn't necessarily mean it's connected to
Yeah, I
a
get you. Yeah, yeah,
path
yeah.
for starting from the
Yeah,
root.
yeah, yeah. I feel like this one would be better with a binary search tree. You
And
get me?
then, well, now I'm thinking like post order and stuff, traversal stuff. I'm trying to
Oh
see.
no, it's gonna be a regular binary tree where we're gonna go start from the root and then we're gonna traverse left and right. Remember? Oh, I don't know. Where, for example, remember when we would search for a number, right? For example, 13, right?
Mm-hmm.
We start at the root, right? Since the root is less than 13, we go to the right, right? Or we check 4 and 8, right? If 4 is less than 4 than 13, right? But 8 is bigger than 4, so we go to 8, right? And then we check left or right. So we go like we check both of them and see which one we benefits us, and then we go there. If you get me? Does that make sense? No, a little bit.
Mm. Well, that's for searching,
Yeah, it could also work for this case.
but you're
Because for example, 5, right? We had 5. Ooh, okay, never mind. Okay, I see where this could go wrong.
we got to make sure it's a leaf node at the end.
Yeah.
So we need to find
Okay.
all the paths that are leaf nodes and then see if they
Orcas
add up to the target sum.
Orcas gave us a hint to do pre-traversal. He says first route left and right pre-order. I'm 90% sure. So pre-order traversal. He said he's 90% sure he would work. So pre-order in order pre-order. Okay. So pre means after. So we're gonna do uh-huh. Doing scatty draw. Ooh, okay. Okay, that's huge. Alrighty.
I saw I saw
Okay.
your face
Bro.
cam
Dude,
go all
yeah, bro.
white.
Dude, it's because I was zooming in because he did his mod, then out of nowhere you go, phew, I was like, wow, yeah, chill, 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 chill. Okay. Oh, we're going bigger.
No,
We're
I just
going
wanted to
bigger.
see. All right, do your thing. Do your thing.
Okay. So, post order means that we have a little thing right here, right? You get me?
Yeah.
So let's use Orca's approach.
Well, you're saying pre-order.
Ew. Code is. Welcome to the stream. Welcome to the stream.
What's up,
Pre-order. Yeah,
Codis?
yeah, yeah. Pre-order, pre-order. My bad, my bad, my bad. Sorry, sorry. So we do something like that. Pre. Okay. Um. I don't see it here. I don't. Pre means before, yes, and post means after. Yes, 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 yes. Post left, right, and root. Left. Mm. Ooh, okay, we're getting nasty with the effects, with the production. Okay, alrighty. Um, submit a video centric from the last time with the other one. Okay, so for post, yes, for post is left, right, and node. Yep, 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 yep. Then for in order is left, row. Yes, 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 yes.
You made a video using the trick from last time with level order. The solution inspired me. Hey, I
Hey,
forgot who said who
it
recommended
was
the solution.
I forgot it.
It was a
I
new. It
forgot his
was
name. It was
Ain. There was a new person that showed up.
no Anas, something with an
Anas. There it was.
Anas. Was it Anas?
Anask.
Yeah, yeah, it was
Yeah.
Anas. It was
Yeah,
Anas.
we literally
And
just did a problem using Anask.
yeah, we
Yeah.
did a problem exactly like that, and then the first problem we did a modification of it, but we did the same approach. So if you want to see the solutions, bro, it's scroll a little bit back and you will get them for sure, for sure. Okay, so here, because we have to check, um, damn, bro, how do we do this? How do we do this one?
I mean, I was thinking like you start from 5,
Uh
and
huh.
then you're once you hit a leaf node, then you like store that previous path you took. And then
Yeah.
once you hit a leaf node again, you store the path you took, like
Uh
something along the
huh.
lines of that. Where
Yep.
if
Yeah.
you do pre-order, you go 5 4 11 7. You hit the
11,
leaf
7,
node, you store that path, and then you're gonna end up going back and doing 5 4 11 2. You store that
2.
path. Or oh oh, wait a minute.
You're on to something.
I'm on to something. Hold up.
You're on to something. Think
Uh,
something called memoization?
memorize what?
Memoization. Remember where we did that
Bro, what are you
dynamic
writing? You're
programming?
writing like hieroglyphics? What is that?
Yeah, bro.
I'm
I'm
sorry,
trying to
my
best.
bad, my
Don't
bad.
worry,
That
don't
was
worry.
rude of
No,
me.
you are good.
That
Nah,
was
it's alright,
rude.
buddy. You
I didn't
are
mean
good,
that.
my
I didn't
guy.
mean that.
You are
My
good.
handwriting's not good, so I have no room to talk.
Maybe memorization, like some dynamic programming,
Oh,
some
they just
dynamic
gave us the
programming.
biggest hint ever.
Okay, so
Yeah.
code
So if
is
it you do 5 4 11 7, does that equal sum? No. Okay. You go to the next leaf. Does that equal sum? No. And then you're like, all right, bet. Then you it reverses all the way back. You subtract as you're going back. You're subtracting that from the total count, and then
yep.
once you go right, then you add each node from there on. Something along the lines of that.
I think so. Okay, yeah. Okay, okay, okay. Let's see. Let's see. So we go start at 5. We have a total, right?
Mm-hmm.
So you go 5, 4, 11, which is 9, 20, and then we get 27. 27 is not target, right? Since it's not target, we go 22, right? So here, do we subtract the 27, the 7?
Yeah, because you call back. You return once the next is
Okay, so we
null.
return
You
7
return. Yeah.
minus 7, so that's 20, and then we add 22. And if it's target, so if it's target, we return true. Yep. Can you hear my background noise?
Yeah, but you're fine.
No. Give me 1 second. Give me a second. I'll be back.
All right. You said, mm, you don't need to subtract. Once you hit the leaf, you make the check. I mean, I was
This is it.
thinking. I mean, I think you're right too, codes,
Yeah.
because when you return, doesn't it ignore the total after that? Like it goes back to the original total, not the original,
Yeah.
but the total it was before that call. Isn't
Ooh,
that
you're right. You're right.
right?
You're right.
So
Yeah,
you
I was
wouldn't
thinking the
technically
same
need
thing.
to subtract.
Yeah. You're just gonna go
Like if the
back.
total was 20 and then you call the next function, now the total is 27. If you return the total and you're not returning total, you're just going back to what total was.
Mm-hmm.
Okay. I think that's how
Alrighty.
it works. I'm not too sure.
Alright. Hey, let's give it a try. Let's see how far we can go.
Okay, you ready?
I'm ready. I'm ready to
All right.
cook, my boy.
All right. Let me drink some water.
Yes, sir. You do you. You do you. Too, my guy.
All right, ready?
Yeah.
So pseudocode,
You
DFS
do.
until
No,
wait, what?
it's a pre-order.
DFS pre-order. Pre-order
No,
is death
pre-order.
first search, though. Like it's a part. It's like a death first search, like
But
algorithm.
I think pre-order traversals it's better because DFS
No, but what I'm saying
is
is
another thing.
pre-order is a part of a DFS algorithm. Just
Depth
as in
first? Oh,
just as in
oh.
order is and post order, right?
I don't.
Like
I
it's like
mean, it works.
umbrella. The umbrella is DFS, and then the inside underneath the umbrella is pre-order. Like it's just like a category.
Mm,
Yay or nay? Chat? Can y'all correct me?
uh, I mean, I don't know. Maybe. I just know that pre-order traversal. I'll call it pre-order traversal, so it'd be less
Okay.
confusing. But you might be true. Does it? 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 Uh, uh.
Think about
I
it.
mean, you can say so. You can say so. You can say so.
Okay. We'll
Yeah.
just say pre-order.
Okay.
Pre-order,
Yeah.
and then
Yeah, but
once until it hits leaf,
uh-huh.
and then check sum. Check sum if not equal target, then what do you have to do after that?
Let me see. Let me
You
see.
just, I mean, it naturally it just with the pre-order
Return.
it just returns. So
Yeah.
return, um, and you keep going until you hit another leaf. Return
Yep.
until continue traversal until next leaf check, and then yeah, and then once
Actually,
sum equals what's up?
the pre-order traversal checks if we reach the leaf though. So
Yeah, like
you get me?
naturally.
Naturally, yeah. So we
The
don't have.
algo.
I don't think we have to worry about that. And yeah, actually, I feel like a pre-order would actually solve this. Okay, let's see. Let's see. Let's continue. Let's continue. Let's see.
Once sum equals once pat sum equals target, stop traversal
Return.
and return yeah, return the path. Oh, return true.
So Orcus confirmed your statement. Pre, post, and in are both of DFS. Yep, yeah.
Okay.
Yeah,
Thank you.
and then and Codis does the same thing. So I was wrong. Yeah.
You weren't wrong. You were misunderstood.
Yeah. Thank you, my guy. Thank
I
you.
got
Thank you.
you. Okay. I think this is. I don't even know if the pseudocode is like kind of. What do you think?
That is
Is
that's
there?
uh
I mean, there's definitely ambiguity to the pseudocode.
yeah, yeah. No, but I think we did it. I think we did. I think
Well, we'll
we
find out.
reached.
We'll find
We'll
out.
find out.
This is gonna
All
be our
right.
approach. Okay. So, do you want to define a function?
Yeah, TFS. You're gonna do root. Just put
My
root.
only
Do
issue
root.
is having the target sum, because I think to have it like, let's say we are subtracting it, to have like self um dot sum equals 0, so that whenever, no matter which function call we're in, we could subtract from it. I don't know. Okay, anyways, sorry.
I think you can just declare it outside and it would remain. The sum equals 0 would remain.
Oh, John Pork's calling.
Jump Works is calling. Yes, sir.
Yo,
Yes,
answer the
sir.
phone. I haven't heard from him in a while.
Yeah. Nah, it's my
What
mom.
the?
She got a call from her brother.
Oh, okay. Whew.
Yeah.
Dude,
Nah, bro. I'll be scared, bro. I'll be running, dude.
I was
If
so
I heard John
happy.
Pork.
I'm gonna put a photo of John Pork real quick.
Nah, bro. Go for it. Go. But that's creepy, bro. But what the
Oh man.
John Pork, bro, dude? That's creepy, dude.
Damn. All right, I'm sorry.
Nah, you
I
good?
just
You good?
every
You
time
good?
I hear the ringtone, I
John
have
Pork.
to. I think of John Pork, man. He was an old friend of mine. It's just, I don't know. But anyway,
Alrighty.
anyway,
Alright.
my bad. I got sidetracked.
Bro, I
Okay,
got PTSD, bro. I'm gonna got nightmares right now.
I'm sorry.
No,
All right,
where
where are
you
we
good?
at? Where
You
are we
good?
at? Okay,
All right.
so we're gonna say if root equals none, return.
Uh
Then
huh.
we
There we
do
go.
DFS. Uh,
We go left, 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 left. They go left. No, we go root. We go root.
e-
They go DFS root. Uh huh. Let's get the traversal down first, and then we can add the summation.
something like that.
Uh.
And then like you do like
Yeah. Yep. 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 Yep.
your
Yep.
little stuff. Okay.
Run that. Let's see. Let's see. Let's see. Let's see. 5, 4, 11, 7, 2, 8, 13, 4. Yes, sir. Yes, sir.
Okay.
Yes, sir. All
So
right.
okay.
All right. So if you want, you can declare 17 out the sum outside the function. Yep. Yep. 0. Uh huh. Do we need the self?
I think so.
Really?
Mm-hmm.
Okay. Okay. Fair enough. Fair enough. Um, and then we can say, okay. Now there, we're gonna add it. We're gonna add num plus equal to the value of root. Yep, 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 yep. And then, so we're gonna check. So as soon as we hit the none, as soon as we hit none, right there in the if statement. Is it in the if statement? No, I think it has to be inside the if statement. No, on 921.
Yes.
I
Yes.
think so. No, because that's what checks.
If if self dot sum equals target sum
Uh huh.
something like return true, or um
Uh huh.
Something where it's
Return true.
where it makes something true.
Wouldn't that become just return true? No, can we do that?
I guess. I mean, because whenever it goes back into the
Yeah, 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 yeah.
whenever like okay, it's return true. Now the next one runs. Like let's say it starts right here. Like it's still gonna have true.
Yeah, I think so. No,
I have no clue. That's why I
no,
always
I
try
think.
not to do that.
Let's see. We'll see. We'll see. We'll see.
Okay, so something
Uh,
like this. Else. Oh. I got it.
return parts. No.
Yeah. Else you're gonna subtract that last sum, the last node,
Oh, okay, okay. So you're gonna
right?
do self that sum. So now you have to keep track of the other one. You good, my guy? um, um, I would say to send as a parameter, right? It's a root sum, right? So we have a sum, right? I think so. Think so. And then equals 0. Yeah. And then we say sum equals target, right? If not, we return sum.
Keep going.
We return sum. Wait, 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 wait. Wait a minute. Oh, wait a minute, 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 wait
I'm waiting, man. I'm waiting for this problem to be over. You're returning. If it's a leaf node,
right there on, I think in line 29.
root dot left. If it's none, I think right here. If it's
Same.
none, like let's say we're right here, right?
Uh-huh.
Let's
And if it
say
left, and if it left, we hit at 7, right? If we're at 7,
yeah,
it's
and
not.
and
So
then
we
we
go
go root
back,
dot left and it's none. We go back. We're at 7
we go
now.
back, we're
Now
at
we
7
check
now.
if the num target equals sum, return true. If not, then
No,
you can.
it returns some. It returns some, right there, it returns some. So now we're at line 29, right? Because we were at left, right?
No, but I'm
Um,
saying this right here, I feel like could be put right here on line 29. The
okay,
if.
let's see. Go for it,
And
go for it,
then,
let's see.
so this will just say return. And then you could say if, um,
Oh, we check if it's the target sum. Yep.
if, yeah, num sum, target sum, something like
Uh-huh.
that.
Else, yeah, else return
If it doesn't, then it'll just keep
else.
going.
Yeah, else. No, no, but you have to subtract though, because
Oh,
you're
yeah,
adding the
yeah, yeah.
7. So you're gonna do else,
Else, num
num sum,
sum minus equals
root
root dot
val,
val.
and then on the DFS return put num sum as a parameter on line 25 and 32. And also 934.
And then if it's, yeah, I think you gotta check it right here again. I think you gotta check it after this. Because then you go to the right. Right is okay. Like let's say now you're over here. We're at 11. No, we're at 2. We went. We checked the left. We wait. 11 root dot left 11. It's not null. You add 11. You check root dot left 7. You add 7. You check root dot left. It's null. You go back. Now you're checking root dot right, which is null as well on 7. So then you keep going back to 11. You check root dot right. And then it's 2.
Why don't we create a base case, right? Where
Okay.
instead of doing, where we can check if 7 is a leaf node, right? So we check if left 7 dot left 7 dot right have something,
Mm-hmm.
right? If it doesn't, we check, all right, um add the sum of it, right? Add sum of it before we reach the sum of line 30, 20, 24, right? We check if it's target. If it's not target, right, we return. You get me? So now we're gonna be at 2, if that makes sense. Think so? No.
What's your issue with this one right here?
I feel like it could be,
Concise.
yeah. And I mean, but let's run it. Let's run it. We can do my approach later on. Let's see. Let's see how this one goes.
There's nothing else to add, you don't think, to this?
Nah, I don't think so.
Okay. So run it.
Let's see. Yes, but you have to print DFS root num sums.
And then if wait. If everything fails, then return false, right?
Yeah. Put on 41. Put return. Yeah.
I think this is an issue right here.
Remove it.
Cause mother.
Let's see. I'm do it by hand. Let me see. Where can I go? Because Codis gave us a hint that really gave me some inspiration.
Oh, yeah. Like what you just said. You need to check if it's a leaf node
Yeah.
as the base case.
For example, we're gonna check. Let me see. Let me write it out. Let me work this out. So you're gonna do exact. I was thinking the same thing. So since we're there, right? We already have the level, the amount of the sum up to 11 in this case. We have something up to 11, right? Well, up
Oh,
to
it's 7.
7, right? So we have to add 7, right? So we're gonna do num sum plus equals root value, right?
Yeah, and then you check if it's equal to target.
No, inside the if statement. Inside the if statement.
Okay.
I think so. I'm maybe
Because if. Oh wait.
because
Okay. Oh,
Because
okay. So you're at
we're
7
checking it.
and you're checking this.
Yeah, if it's 7, that means that 7
Oh,
is a
okay,
leaf node.
okay.
So we have
Yes.
to add 7 into the num sum, and if and then we check if num sum equals target, return true, return true, right? Else don't do anything, right? Okay, no, you have to do else. Uh, you do return, I think. Wait. No, I think everything, all of this has to go inside the if statement. Like from line 24 all the way to 28 has to become all inside the if statement.
Which if statement are you talking about?
The first one, the if not.
It goes in right here.
Yeah, right there. Yeah, because right there, because on line 21, that if statement, we're checking if 7 is a leaf node, right? If it is, we add it, right? We add it to the root value. Then we check if target, okay, return true, right? Since it's a target. Else, right, we return. We don't do num7, don't do, wait, um, yes, you do num, yeah, exactly like that. Then you return, right? And then, mm, mm, let me think. Root dot value. Okay, here is going to be a little bit complicated because we have to go backtrack to the right, right? We have to give it the original value.
Well, if you're returning, then that means
That we can do.
else you do the else return. Now you're technically aren't you back at 11?
Yeah, I'm back at 11. Yeah.
You were right here when you went to 7. You were 11,
Okay,
you did
right
root
there.
dot left, you
And
check.
then it returns and then
Now
go to
you go
right
to the
and then a
right.
right.
You're at
Yeah, okay.
11
Yeah. That works.
and then
Yeah, and then a left is gonna return right, and it's gonna go to the right, and right is gonna do the same thing. Gonna do inside the if loop. Root dot left. Here's 2. If we have loop, if we have something left, if we do, we add the sum, and then if num goes into the target, we return true, right?
mhm.
If that makes sense.
No, I get you.
Yeah.
Now now if it does all of that and it's nothing, do you do return false
The we return false. Yeah.
or cuz sometimes I think that it returns true and then let's say it was nested inside another call and that other call was the parent function call, let's say
Oh,
it goes
okay. It
all the way to
doesn't
false
carry.
and it changes it. Like
Hmm
this will
hmm
always return false because once it hits the end, that's going to hit return false. Unless return true just eliminates everything and stops
I
from
think
there,
I
right? Or
think it
no?
limits because it backtracks, like it goes up the ladder. So it's return. You get me? I'm not sure, but I think so. Because since it returned true, that return true gets carried to the car. The return true gets returned to the car. That true return gets returned to the car. The true gets returned to the car, like to the previous parent car, to the parent car. Um, to my understanding, but I'm not sure. Let's see. Let's run it. Let's see how this thing works. Or are you still not confident?
I'm just thinking real quick. Mm, okay, hear me out. This might, and maybe it works like this. Okay, I guess I'll run it. I'll run it. We'll see.
Maybe not. Hopefully it does, but I don't. Yeah.
What is it saying? Oh, right here.
Okay.
There's all. Oh. If. Does that fix?
Yeah, I think so. Hmm. Hmm, 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 hmm.
Oh.
Okay.
Because
So cool.
root.
Cody's giving us some tips over here in the chat. I don't know if you want to read them.
Yeah. Let's see what's up.
Uh, so he says return false is fine there. The issue is with the edge cases. You're not checking if you're fully traversed a branch. Okay.
You're not checking if you fully traversed a branch. You're not checking if you fully traversed a branch.
I guess we just do another if statement with the if root and return. Remember how we had it previously? Uh huh.
Oh.
Yeah.
Yeah. Okay. You think
I
so?
think that would work. Yeah. Ooh. Ah.
Here's what I was thinking. Is that you can have a variable name and this will return, let's say true is returned from this function call. You could
Mm-hmm.
say I don't know, I'm just thinking if left or
Or
right return true. This might be like totally off. Return false. What were you thinking? You're also
mm,
double adding root val. Oh, thank you. I don't know if this matters, but I'm just
not
writing that.
root left, if not root left. Okay. I was thinking if you want to solve that, I think you can just make a global variable and change it to
That's also
left,
another way.
and at the end just return the global variable. You get me?
Yeah. But what's the problem with this one? What not what I put. I'm just saying what's the problem with this test case that it gave us?
I think it's the same issue. Return sum. No.
I think it's because we're double adding.
All
I think
right, go
that's
for
what
it.
the issue was. Should I change it back to what it was?
Yep. Let's see. Let's try it out.
You little.
So Cody's over here cooking. He said, so when you're at the leaf node, you don't want to add root out because that will already be taking care of DFS. So we have to delete 26 and we have to go back. There, right there, and delete. Yeah, that one right there. It's not working, Codis.
We
It's not
should
working.
we should add some print statements. Let's figure this out because
Yeah, let's do
we're going in blind,
after like on the very top
right?
line of the function,
Okay.
do print num sum.
Is it also because we're not rich? Oh, I don't know. Let's see. 0,
So okay,
5,
let's see. Let's see. So we got
9,
0, 5, 9,
20. Yep.
20.
It doesn't go to 27.
Okay.
Then it goes to 9.
Now do on 26, do the plus 7, the num sum plus root, on the if statement on line 26,
Uh-huh.
right there. Do the num sum plus equal.
Do I erase this one?
No. Leave that one. Leave that one. Because I wanna see if that changes something. Might be wrong. 20, 13, 17, 17, 20. GI. Okay, so code says you're early returning from the leave node. Early returning.
Yeah, because we're not going. It's never hitting 27.
Yeah. It's not hitting 27. No, I think it's all
It's
right.
this
Do
right
another
here.
print.
It's
No,
if.
do another print statement on line 27. Right there. Yeah. With num sum. Yeah, Ritzy. We do hit 27. And we do hit 22.
But we automatically subtract it immediately once. Oh, okay. I mean, we hit
So we
22
do
right
5,
here.
9, 20,
We hit 22.
20, 27. Yeah, so it is working. That backtrack is working. Right? And then we go 22, and then we go from 22, 11, then we go 5, 13, 26, then we go back to 8, to 13, to 17,
5, 8,
to
13 plus
18,
13, and then
13, 17.
8, 2, 3, 13 plus 4, 7, 18.
So we're traversing somehow.
So
So
that's
okay,
all
so
working then. It's
yeah,
just the
so
true
you're
then.
early.
It's just true. It's not right.
Yes. Okay.
I
So
want to try
code is
something,
said. Okay.
but keep saying what you wanted to say.
Code is said to like subtract. After subtract, you don't need the return.
Oh.
Okay. Okay. All right, run it. Let's see.
Oh.
Okay. Submit it.
No, I don't want to submit it. I don't want to submit it.
Okay.
Or what something I like to do is go into the discussion and then look for test cases because they write them down.
Oh, sneaky.
Yeah, but I don't know if they do them for this one. Or even some where people are having issues. Like they're like, why isn't this one not working?
Oh man.
All right. Well, you just want to do it?
Right there.
Where?
Go there. Right there now.
Where?
Right there.
Oh, just use this one?
Yeah.
All right.
Hey.
Come on,
Wait,
it's
wait,
life.
wait, wait, wait,
Okay,
wait,
okay.
wait. Go down, 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 go down. Go to the accepted over here on case 4.
Yeah.
Can you change the target sum to -1? Because this guy had it as -1.
Oh, okay, okay.
Yeah. Okay, works. Works for me.
All right. Ready?
I'm the alright. Go for it. Go for it.
Hey.
Yes, sir. Yes,
Hey.
sir. Okay. Code Coda says to be consistent with other pronouns, you should understand backtracking. Okay, yeah, we should learn how to do it without the if statement at the bottom.
Say that again.
We should learn how to do it with the if statement at the bottom.
Without this.
Yeah, try doing it without. Yeah, without that. Yeah, yeah, yeah. Without like yeah,
Well,
and
what's
then
the
remove the
hacky
verb
way
one.
of what's the hacky way he's saying? What are you saying? Like
Like yours, like the I or thing. I think so.
this.
Yeah. Let's see. Do it like that and do run. Ooh. Okay, never mind. Okay, that's nah. I don't think it's gonna work.
Yeah.
Yeah. Hmm.
But Orcus
Hey.
also said.
Yeah. Return I or yep. 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 He's. I think Orcus is saying the same thing. So that thing. That. So I L is gonna become. Okay. I think I get you now.
Yeah, it's
Uh huh.
because that it assigns
It's a.
it to L like true, and then if
Yeah. Yeah.
it's
Yeah.
not,
Yeah.
if it's never gonna hit true, then it's always gonna be false. So
Yeah.
you
Yeah.
check
Yeah.
that,
Yeah. Yeah.
and then codes is saying the subtract part.
Oh, so after on like in between 36? Because I know if we go in and then so on line 36, well now 35, right there you subtract. Hey Kyra, welcome to the stream. Welcome to the stream.
I feel like it because he was talking about something like this right here, something with.
Yeah, but on 34, on line 34, like in between those lines.
Maybe, hey, maybe we need to phone a viewer for this explanation.
Phone a viewer. Codis, if you want to help us, then if you're in the Discord, hop on the call, my guy. Hop on the call. If you want to hop on the call, we're open. Okay, after 34.
Okay, after
Okay,
34,
right there. You
you
subtract.
want to subtract.
Yeah, but you have to delete the L so on the line 28. Yep, 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 yep.
Oh,
Okay,
hmm.
okay.
As you backtrack, once you hit right, then you're going back. Wait, but how does it subtract after it goes to 7? Once it hits 7, oh, it checks left, right. Okay. Wait, no,
It
no.
goes left. Yeah, I
It's
think
at
you're right.
7,
Yeah, because it checks left on
left, right,
7, and it's gonna hit the root, which is return. It's gonna go to right, and it's
back
gonna
to
return.
11,
Yeah, and then
and then
since
check
7,
right. That doesn't
yeah,
equal,
check.
let's say that doesn't equal 22, then you just minus.
Yeah, yeah, because on 7, right, it's gonna go left. It's none, right? Because it has nothing. So it's gonna go right. It's gonna check something, and it's nothing. And since 7 didn't hit the case on line 24, right? That means that 7 is not the target. So we're gonna subtract the root, which is 7. You get me? So we are in 7, right? We're in 7. Just
Yeah,
imagine we're in
and it
7.
checks its child, its left
Its
and
check
right
is
child. Once it
exactly.
passes that, then it subtracts
And
itself
exactly 7, and then we go back to
back to
11,
11.
which we
So
go
11 was
to
right here on line
yeah.
32. It goes to
Uh-huh.
33. It checks the
And now
right.
we're
Let's say
uh-huh.
the sum isn't the target, and then it was like, okay, 2. It checks 2. It checks the left and right. Blah 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 blah. It minuses 2, and then it realizes it never
11.
hit this. It never hit the sum. So now
Yeah.
11 gets subtracted by itself.
Yeah,
Goes back to
exactly.
4. Checks the right.
And
There's nothing there. So now
there, so
4
we get
subtracts it
subtracted
from
by 4.
itself.
Yeah.
Hmm.
Uh-huh. That is
Okay.
smart. All right, code is spitting some fire.
And then I'm confused on line 25 on you add this and you add line 32.
Yeah, because on that one, on line 30 34, where you're checking if you're in the leaf node. If you're in the leaf node, we add our value, and if that value is equal to target sum, then we return true. Pretty much. Wait a minute, that does not make sense. Hmm.
Because you're saying this is saying
Yeah.
if you're a leaf, you're gonna add it, but if you're not a leaf, you're gonna add it again. You're still gonna add it. Or
I mean, it's
mm,
because here we return true, so we skip the addition part. We skip the addition part, so we return true, and then since we return true,
code said you
hmm,
also would need to double add if you check the leaf after you add. Is he talking about this one?
think so.
But that's why I'm confused. Like, how did it work? Let me see. All right.
No, I don't think that's gonna work.
Okay. Hmm.
Okay, so you add on 23. Add on 23.
This one right here.
Yeah, move it on to 23.
First shield.
Versio to the
What's up, buddy?
rescue. Haven't seen you in a while, my guy. Yeah, and then delete line 27 or the num.
This
Yeah,
one.
that one.
Wait, this one.
Yeah. How you doing, Versio? I think that works. Yeah. Okay, this one makes a lot of sense. So we add 7, right?
Okay.
And then we check if it's a leaf node. If it is a leaf node, we return. If it's a leaf node, then we check if it's targeted to some, then we return. Else, we check the left and right. Okay, that makes sense. That makes sense. At 2, for example, right? We add 2, right? On line 24, and then we check if it's a leaf. Since it's a leaf, we return true. True, and then does that make sense? A little bit.
Yeah. Let me see how it was before.
Over here, you
It's a
were
leaf. You're adding to leaf. You're adding it.
for sure. It's understandable, my guy. Hopefully everything's going good and everything's working out. And I'm glad you were able to join us today, for a little bit. And I'm glad. Hey, it's gonna sound a little bit weird, but hey, it's good that we have work every single day, right? Even though it's a lot sometimes, it's stressful. It's great. It's a blessing to have work every day. That means that we're doing something right, right? And hopefully everything's going good, and keep it up, my guy. And we're here, my guy. We're here. We're here.
All right. Well, shit. I mean, shoot.
Hey,
Hey,
yeah,
my bad. My
yeah.
bad. My
Nah,
bad.
no worries, no worries, my guy. That
Well, I mean, it works, I guess. So
this one fried my brain. This one fried my brain.
I like the ending though. I like how. Oh my.
Damn. I want to learn how that works. That return true and stuff.
This
Yeah. No, I know how it. I know it works. How it works, but I just want to know why do we have to do it like that? But we'll see. We'll see. Oh, hey, bro, look down on the left, bro. Look at down at the left. Down on the left. More challenges. Pad some too. Woo! Yes, sir. Yes, sir.
return all the root to leaf paths where the sum of the node values equals target sum. What the?
Damn.
Good night, Shield. Good seeing you,
Damn.
bud.
Hey, good night. First you. Take care, my guy. God bless.
All right. Well,
Hey, bro. Good
we
sesh.
think we'll have to
Good
leave
sesh.
that for
Another
another
day.
another day. Wow.
Damn, bro. It's midnight over here. Bro, good
Let's
session, my
switch.
guy.
Let's switch it
Good.
to intro outro.
I'm on a 7 right now, my guy. I'm
You got a
on a
seven?
7. Yeah, I just want to forget about LeetCode today. Right now, I came up motivated, ready to go. Now, I just want to eat some cereal, bro. Some cinnamon toast crunch, bro.
Cinnamon toasties.
Yes, sir.
I'm at. Like I'm around the same range as you. But what I'm stuck on was the adding part,
Yeah.
and then yeah. So I guess I'm a just because I'm gonna just put a 7.1. But all right, that was
All
a
right.
good stream.
Did you put 7.1?
Yeah.
Just just put 7, my guy.
No,
It's
I think
alright.
I'm at a 7.1.
You're 10, but yeah, damn, bro. I love like the
The
precision.
precision, yeah.
The precision. 10.1.5678.5.
Yeah. Yeah. So you never know. Maybe one day my insane level would be 3.14.
Three.
Never know.
It'd be pie. Bro, we start
But
doing our inside levels on radians and stuff on
yeah,
degrees.
we're gonna do log n,
Log
log
in.
log 5. See you, code. See you later. Thank you
Hey, coach.
for
Thank
helping
you.
us.
Appreciate it.
But yeah, that's about it.
Bye, Orcus. Take care, Orcus.
I don't think there's any announcements other than thank you for 250 subs. That's a good
Yes,
milestone. Halfway to 500. We stream weekly. Get the bell notifications going because sometimes we stream in the morning. And if you're available in the morning and you want to just do some LeetCode in the morning, you can check us out. But it don't matter. You could watch whenever y'all feel. And then I think that's about it. I don't know what else.
Same here.
We're gonna stream again next week, the usual.
Yes, sir. Yes, sir.
I want to get some videos posted, so you never know. Maybe some videos are gonna be posted, but they're just gonna be the clips of the stream. So,
all right, fair enough. Fair enough.
No additional things, but I think that's about it.
Hey, maps in 6. Maps in 6.
Mavs in 7.
Maps in 6.
Mavs in 7, baby.
Maps in 6. Maps in 6.
Let's
Calling
see.
it right now, right here. Maps in 6.
What else? I think that's it.
Yeah, same here. That's it for me, my guy.
All right, Jose, you do the outro. You say the last words.
Yes. All right, guys. Thank you guys for coming in with us, for bearing with our hard heads. Well, with my hard head, right? That like we do hear things here over there differently, blah blah. But thank you guys for supporting us, for being here, for helping us, for helping this community to grow. Thank you for 251 subscribers. We're halfway there. Make sure to get in this Discord. You know, I think we have 60 spots left. We're running out. I don't want you to miss out. But other than that, thank you guys for coming in, for tuning in, and hopefully you have a great, wonderful night, evening, day, morning, whatever your time zone is. Just have a great, wonderful day. You guys take care. Sir.